Yeah, so I didn't do any presentation slides, so I can present myself. Tomas Riha from WirelessCar. I know a lot of people here because almost everybody is at WirelessCar, and I'm always a little bit conscious about speaking in front of colleagues because I mean you guys hear me talk all the time, and I'm kind of surprised you're not fed up with me, and you also always spot my lies, so it's always a bit special to talk in front of colleagues. At WirelessCar, I'm platform area architect, it's called, but I'm basically architect of all things that we do in the cloud and our continuous delivery. I've been working with continuous delivery for quite a few years. I've been talking a bit about it and been saying that it's the biggest and most important thing that has happened to software development in the last X number of years. I've stopped saying that. I'm saying that this is now serverless architecture. And I'm going to talk about why I think that's so important and why it will be the big hot thing that everybody talks about for the next 5 to 7 years. Whoa, wrong button. There we go. Basically, this is what we do. And then it's more, but we do a lot of crap, boring stuff that is in gray, that has very low value to our business. We're exposed to some risks that we need to manage as well, and but it's really kind of just this in the middle that is actually the business value that we as developers provide to our company. And if you would play with the idea that you have a startup company and you need to assemble the tech team that is to work with the startup company, then yeah, you need some developers, some architects, whatever, and then you need somebody who does the servers, the networks, the databases, the backups, and I don't know, 20-25% of the company is directly involved with that work, and then it spills over at us developers as well. And then within developing, I mean, we do a lot of just boilerplate coding and configuration of runtime environments, JBoss configs and whatever. And all of that that's not green is waste. And that's basically what serverless architecture aims at, removing all that waste around us and letting us focus at the green, nice, fun stuff. Basically, we've been moving stuff for quite a few years from environments on-premise into the cloud. And a lot of the shifting into the cloud has been basically utilizing infrastructure as a service. So getting Linux runtimes instances up and running, getting maybe a Docker cluster up and running, and that's still infrastructure that needs networking and firewalls and security. Databases as a service on AWS, the RDS services, basically, yeah, you do get a semi-managed Oracle or Postgres instance. You don't have to care about the underlying OS, but you still need to manage the storage, the extending of table spaces, your indexes, and all that that type of work that comes from having a traditional database infrastructure up and running. So the gain of moving to infrastructure as a service in the cloud, it's still big. It removes a lot of waste. Especially, I think it improves your security situation because, to be honest, the people that build and manage the instances at Amazon, Google, or even Microsoft, they are much more skilled than the people we at Volvo can employ. I mean, we have a lot of good people, but it's nowhere near the same ability of people we can employ as they can employ. And that's why I think the entire discussion of private clouds is a just load of horse shit from box vendors who want to stay relevant. Because we, as the company who has the on-prem environment, still need to be good at security, good at networking. We still need to manage our boxes, and we still need to have that competence. Now we can have much less of that competence, but we still need it when we running infrastructure as a service, because we're still managing a lot of stuff ourselves, the Linux environments and stuff like that. But it's getting better. And then when you move towards the platform as a service, which serverless is part of that, but platform as a service is more, then you actually get your get much more managed. You basically have APIs that you're accessing your data, which is stored somewhere, and that API is secure. It has a high level of security. All the processes around the data and the management of it is in a very secure way done. So it removes the risk, but also when you move towards platform as a service, you remove all the waste of provisioning infrastructure and networking and stuff like that. And that's when you really can start focusing on delivering value. I'm going to talk about 4 core AWS services that are aimed towards building custom developed applications in a serverless way. The API gateway is pretty much what it sounds like. It's a API gateway for managing REST APIs. It's got a few nice characteristics. It's got very good scalability. It utilizes Amazon's CloudFront, which means that it's distributed CDN across all their edge locations. And you get very good integration with the different kind of authentication and security solutions and a good manageability. So, but it's pretty much an API gateway. Then we're going to talk about Kinesis, which in my opinion is basically the heart and soul of a well-built application on AWS. And finally, somebody has done PubSub right. I've always liked the PubSub pattern, but I hate JMS. And I hate queue systems because they cannot support queues, which is kind of, consumer disappears, stuff starts to queue up, and your AMQ or whatever falls over. And that's why you can't really do PubSub in a good way with higher loads in with other solutions. But Kinesis supports that really well. And then I'm going to talk about AWS Lambdas, which is AWS take on function as a service. AWS, Google, and even Microsoft have some concept of functions as a service. Conceptually, they're very similar, but I'm talking AWS. And then I'm going to talk about DynamoDB, which is a big table database as a service. It's got its trade-off. It's maybe not as super nice feature-wise as Cassandra, but it is as a service, and you don't have to manage a Cassandra cluster, which is a lot of work to do. So let's dive into it. Not much more to say about the API gateway. I mean, automated publishing of REST APIs with good integration, good support for throttling as well, different usage plans with different throttling based on API keys and stuff like that. It is what it is. It's an API gateway, but an API gateway is important because I'm going to talk about it later, that when you migrate from a traditional server-based environment, I mean, it's important that you have your APIs well defined, and then you can do whatever you want, plug and play underneath the API gateway. So it is a very important to have an API gateway as a standalone first-class citizen in your infrastructure. Kinesis then, it's basically a big log file, or Amazon call it a stream, which it is. You have a key and you have a payload, and it's the responsibility of the consumer to know which records have been consumed. So you have your own pointer, and you handle the persistence of the pointer on the client side. So this consumer knows where he is, and consumer one knows where he is. So they can consume the stream independently of each other. And there is no such thing as a message getting removed once everybody has read it. The end of the stream expires after a configurable amount of time, which is default, it's 24 hours, but it can be tuned up to 7 days. So you have basically 24 hours to consume your stream, and you do it independently of each other. So, and what you provision here is that you provision how much throughput you want on the stream. Practically that is done by creating more and more shards of the stream, so that it becomes kind of like a beehive looking thing with data flowing through it. And either say explicitly to keep stuff on a certain shard, or the publisher writes it randomly on the shard. So that depends on how you need to maintain sequence in your message processing. But it's basically you provision throughput. You say how many shards you want. By each shard you get a amount of throughput, and you pay for the throughput. Then there's a lot of nice side features of using Kinesis. There is a service called Kinesis Firehose, which basically takes whatever is on a stream and pushes it to a storage media, either a DynamoDB, a S3 bucket. S3 is a simple object store, basically, or into Redshift, which is for analytics, or into Elasticsearch. So basically you get, what it does is that every certain amount of time it takes chunks and moves those unprocessed onto different storage types. So it's just super nice if you have data streams coming in, you dump it into some sort of data lake for analytics, and you have it there. It's nice for backups as well. If you have the full expiration time to reprocess, but if you haven't been able to do that, you just basically feed what's in there back on a stream, and you can reprocess that. Everything of this is as a service, so you basically just say you want a fire hose from that stream to that bucket. Then DynamoDB, which is basically a database as a service where you define your tables, and you have an API for accessing your data on your tables, and you manage permissions to the tables using AWS IAM, which is identity management in AWS. So you have nice security for your data, and you provision how much you want to read and write over the API, and there is a small amount of cost related to amount of data, but it's basically all you're paying for is read and write throughput. It's not really a significant amount of money you're paying for storage. I'm going to talk a little bit about what DynamoDB is. It's a wide column data store, which is similar to Google's Bigtable. I said Bigtable earlier, but I tend to call all of them Bigtable and not wide column, but the theoretical name is wide column. and Cassandra and HBase. And they are defined by the fact that each row has its own data model, more or less. So you have a primary key or a set of keys that define the primary key of the row, and then you have attributes which you can dynamically create in runtime and add on more columns. It's typically very good to do time sequences where you basically have event. Say you have a dialogue between a machine and a system, and then that dialogue has a set of events in it, then basically just add them on as more attributes. And it's super cheap to append attributes to a row. And in DynamoDB, the way it works is that you have a hash key and you have a range key. So it's basically one key that determines on it's stored in that bin, and then it's a range key that sorts it. So you always do your queries on the hash key and the range key. So the database always goes there, looks at the sorting, grabs your data, which makes it scale really nicely. So yeah, basically the hash key of the bin 1, 2, 3 goes into that box, and then that one goes in there, that one goes in there. And it's a little bit restricted in that because you can only query at those two keys. But what you can do is that you can create basically materialized views. It's called one more ahead. Yeah, so you can create views where you say that I want to have, it's called global secondary indexes, but it's comparable to a materialized view. So you basically say that I want a global secondary index which is composed of the VIN and the fleet ID. And I want the view to expose all my columns. And then you query, if you want to have all the events for a fleet, then you query on that view. So basically, and that's kind of the thing with all the NoSQL databases, that when you model around them, you need to know your data access patterns and model around that. And it's hard to change the way you access. And that's the good thing about relational databases, because you make your normalized model and you don't know from which side to access it, and you can access it from whichever side you want to. But with NoSQL, you always need to know this is my write scenario, this is my read scenario, and model around that. And the nice thing is that microservices usually have very simple data models because you know how you access your data. So that doesn't really become a problem. But as I said, when doing microservices, I like to use DynamoDB as a database. If I would be working with a bigger, more complex data model for a more monolithic application, I would be careful about just switching the database and not re-architecting and doing the entire system into microservices. And the global secondary indexes are basically treated just like tables that are maintained by the database. So basically, the hash key of the index is stored in a bin, and the range key is how it's sorted in that bin. So it works identically, and you provision how much read and write you want on each index and the table. So you can have different tuning on that as well. Yeah, and then nice thing is as well with DynamoDB is that it has a feature called DynamoDB Streams, which is basically the triggers of DynamoDB, but they work the same way as a Kinesis stream, basically. So you have a stream with the with a key, and then you have the event, what happened on that database record, and you basically you get the old value, old row and new row, and then you consume that event from the stream with the separate consumers, just like you do a Kinesis stream, which is very powerful. So on to Lambdas, and I'm gonna talk a little bit later about how all the components interact into an architecture. But Lambdas is functions as a service. You can write the functions in Java, Python, or Node.js. Depends on what you like. We at WirelessCar like our Java, and yeah, because that's where we're coming from. But we see that the Node.js is actually quite good alternative for Lambdas for certain use cases. But basically what you do is that you have a method, and this is a Lambda that is consuming a stream. So for each Lambda, you can say, I want it to trigger on events coming from S3, from a stream, from a DynamoDB stream, from notifications, from the API gateway, and the events that come in, they are sent to the Lambda service as JSONs, and the Lambda service marshals them into a POJO for you. So you basically you put your POJO that represents the incoming payload on your method, and you tell Lambda what your method is. So I say that request handler is my my entry point method, and it will translate the JSON of the Kinesis event into my POJO, and the context object there that I have is the Lambda context object, which basically tells me a little bit of what account the Lambda is running in and what the name of the Lambda is and stuff like that. And that's optional, but that one is really the only boilerplatey thing that is tied to Lambda, and you don't need it. So I could just basically have my Kinesis event there. And when I consume a Kinesis stream and I set up my Lambda to do that, I can tell the Lambda how many records I want to consume per execution of the Lambda. And that's quite useful, because if you have a lot of traffic coming in, then you don't want to start, because you usually, I mean, you maybe have some kind of little bit of logging and metrics and stuff around your consumption of the stream, and you want to keep that to the minimum compared to the processing of the records themselves. And it's a trade-off, because I mean, the more records you get in at once, the faster you process them. At the same time, you need more memory because you load more stuff into your Lambda. And what you pay for with Lambdas is execution time per memory provisioned. So I say that I want a Lambda that is in a runtime which has 256 megabyte memory, and then it executes, and it takes 200 milliseconds, and then I pay for 200 milliseconds factored by the size of the memory. If I increase the memory and I run for 100 milliseconds because I run faster, and I do get more CPU with scaling the memory as well, then I pay the same if I run in half the time. So if I run at 100 milliseconds for 512 megabytes instead, then I pay the same. So you want to use that for tuning, and the amount of data you consume kind of goes into your tuning of the Lambdas as well. But basically, I get my Kinesis record, I get the data from it. It's a string. I marshal that into my whatever POJO that is the data event itself, and I do my business logic here, and then I'm done. So, and that's all I do. I package that into a jar file, and I upload it to the Lambda service. So it's quite a small footprint for executing my code. And yeah, as I said before, you can have multiple consumers on a stream. So for example, say that we have a stream that is positions from a vehicle, and then I can have one service that is building up journeys with snail trails and whatever, and one that is just updating the latest position of the vehicle for a dashboard view, and then they can consume the stream independently of each other and build different services. And you can also plug in the fire hose here to send data to a BI system or whatever. And when the Lambda consumes it, you don't need to care anything about the pointer to which records you have consumed and whatnot. It's done by the Lambda service for you. Just a little bit about how the Lambda service works. This is my interpretation of how it probably works behind the scenes. I've not seen any of the ones who build functions as a service be very verbal about how it's done, but this is my interpretation how it works. So there is a Lambda service with a event listener that you have configured. I say that it should listen on my Kinesis stream, and when it sees that something happens on my Kinesis stream, it starts up a JVM, probably somewhere the JVM is already started with the Lambda engine on it and waiting. And it takes and loads my jar file into the Lambda engine, and it starts executing my code. And this is why sometimes it's nice to actually use Node.js, because Java is heavier on the footprint, and starting and loading the Java application has a little bit of a hit to it on the first execution, while as the Node.js, I mean, it's a text file that is started basically, so it's much faster. Then on the subsequent calls, the application is already loaded and it's there, so it just executes right away. And Amazon keeps the Lambda instances hot and warm for you for a certain amount of time, which is more than a few minutes, less than half an hour. It's also one of those undefined amount of times. I would say somewhere between 5 and 20 minutes is what I've been seeing that they keep them warm, basically. So, and that's kind of good to think about if you have a low usage scenario. I've heard a lot of startup companies which have maybe an app that's low amount of traffic. They tend to get the hit of the loading of the Lambda a lot, and that's where Node.js is a good option compared to Java. And then, as a lot of requests come in and are processed by the application here, they kind of notice that this one is getting hot, and they scale up more instances for you and load more of the containers for you. So you actually get something like this, and you have your application in many instances, and as many as you need, depending on how much work it does. So it's basically, there is no real, well, there is a limit, but it's one of those limits that you can request an increase on. Amazon has a lot of soft limits where they're there to protect you from inadvertently overusing and being overcharged. So there is a limit on concurrently executing functions and you can just request it to be increased if you hit it. So you can basically have as many Lambda engines running as possible, as you need in AWS. So you don't really need to care about the scaling of Lambda. You get it out of the box, and you just say how big your the memory of each box should be. So let's look at some sort of server-based microservice. Strange way that arrow goes there on left, but this is basically how our microservices at WirelessCar look. It's some kind of machine-to-machine data feed coming over AMQ, and then we have consumer APIs using REST, and it's built basically by having elastic load balancers, auto-scaling instances, and Postgres database. And those auto-scaling instances also consume this queue. So that's basically how we build it, and it scales and it scales up, but problem is that it doesn't scale down very well. So if you have like your QA environments and stuff like that, then you have your servers there and they're there and running, and it's not really scaling down because you're paying per hour of instance up and running instead of per execution cycle of your code. So you really want to remove these ones, and you kind of do want to remove that one as well, because Postgres is still a pain to manage compared to DynamoDB, and you definitely want to remove the AMQ. Whatever you do, you always want to remove AMQ. So what you can do with Lambdas instead, you have your API gateway, then you have your separate functions for your for different endpoints on the APIs. You have your one put function and one get function, and those are independent Lambdas. They can of course be from the same jar file. They can be the same class, but they are defined in Amazon as different Lambda functions. So you actually get independent scaling on the put and the get. So your get can typically scale more, and the put can be using less resources. And then you have your data feed using Kinesis instead, and you have your batch consuming function, which puts stuff into the database. And then just because you can, and it's so easy, you do a export data function to your BI system just because it's there and available, and you can do it without having to even care about it. So that's how the similar microservice would look in built serverlessly instead. And there's an important thing here, and it's still maintaining the boundaries of a server in your of a service in your architecture. Otherwise, it's really easy that we kind of move back to the 90s. I see some people here that I know were actually working in the 90s, and then we were integrating over databases. It was a lot of fun to have different systems talking to the same schema, and you would never be able to change that because the data schema was actually the contract. If you take this boundary away and you just spread out Lambdas across your landscape that actually consume the same database, they totally lose control of what's happening within the database. So it's super important that you retain your boundaries of the service, and you always utilize the service through a strict API which has a contract and preferably contract tests, and so that's basically how you want to maintain your architecture. And a little bit here about how I like to build the services. Talk pretty much about all the things. I've not talked too much about logging, but Amazon has a logging service, which is CloudWatch, which is basically, it's not a full-scale logging solution where you easily search logs across all your different applications, but it's a, I would call it intermediate log storage solution. So you get your logs more or less by default from your Lambda into CloudWatch logs. And then you can have a fire hose from CloudWatch logs into your Elasticsearch. So it basically just feeds the logs in there, and you solve your central logging problem in a quite simple and nice way. And so if you have the landscape of stuff that is doing PubSub, then you want to have the publish stream. And I'm drawing it here because I think that this one should be a life cycle of its own, actually, so that you can reprovision your application without taking down your publish stream. That's kind of important. API sits on the outside, should be the same way as well. Probably the database as well. So you kind of should divide still this box into different life cycles. And then you just build more of these small boxes where and they subscribe to each other. And then eventually you will get, I'll skip ahead a little bit, this is kind of how I would see a runtime environment look. Still my arrows have been a little bit, you could actually build a separate event bus if you want to build your application that way. So you have like an event bus that a lot of services are consuming. Then you maybe have the event bus sharded on different types of data into actually different instances of the event bus so that this service has its own. All of this is done with serverless. And then you have some kind of central config solution, which you also build with your serverless architecture. So you basically have a REST API for loading, and then you can have a Kinesis stream when the changes to your config are published to get your updates that way. And then you have your central logging here with everybody just feeding their logs into Elasticsearch using Firehose. Or if you want to kind of clean your logs or do some kind of indexing in Elasticsearch, then of course you just write your own Lambda and consume the CloudWatch logs, log groups, because they as well work basically as streams. Then if you look at GUIs, we want to add that. We want that to be serverless as well. Then you can put your GUI in a S3 bucket, and it's published on the net right away, because the S3 bucket can be a file hosting. If you want to have CDN capability, you connect CloudFront on top of that, connected to that S3 bucket, and then you get the global CDN from it. And still no servers and still no networks. And then, the last and final bit, I think this is my last slide, is talk a little bit about security. Basically, each resource, there's different types of security. For end user access, there's a service called Cognito, which is basically, I'm going to minimize a little bit, but it handles your OAuth authentications, and it plugs into a lot of different authentication sources in the background. So you can authorize your end users using Cognito, and then you can use AWS IAM for machine-to-machine communication to lock down the APIs even more and the services. Then we have a little bit about encryption as well. DynamoDB and Kinesis streams are not running on encrypted storage, which means that if you want the data to be encrypted, then you encrypt your data. And a lot of security people kind of get worried that, oh, it's not encrypted storage, cannot use this in a big enterprise company. Yeah, but encrypted storage is kind of useless. It's much better to encrypt your data, actually, because if you have like an Oracle database running on an encrypted storage, so you log into the database and you see the data, you take the data down from within the database, you give the data out. If you actually encrypt the data, then only the people with the key to the data see the data, which is much better anyways. And it's important to know it and be aware of it, and I think it's kind of well documented in Amazon's documentation how different things are encrypted or not. If you store stuff in S3 buckets, then that's encrypted at rest. Same your Elasticsearch can be encrypted at rest as well. So there is some encryption at rest here as well. Yes?
All the stream source encrypted?
No, they're not encrypted. So you need to, if you wanted it to be encrypted in transit, then you actually encrypt your payload when you put it on the stream, and you decrypt it on the other side. So, Amazon has really nice tools for doing that encryption with their KMS service that handles keys and encryptions for you, as long as you're okay with them having the root certificate. And that's more a political discussion than anything else. So by building applications like this, we can basically get rid of the server maintenance, the network maintenance, boiler code, and everything. But you need to do one thing. You need to automate, because you will have a lot of Lambdas, and if you think that you can sit and deploy the Lambdas into a production environment by clicking in a GUI or using some kind of CLI to do it, then you're wrong. You need to automate it, and especially for serverless, there's a framework called serverless.com, which basically automates the deployment of Lambdas and building APIs to it. But it's not really hard automation to do. It's I could say done in days, but yeah, it is still easy because it uses all the Amazon automation stuff that you have with the CloudFormation and everything like that. So it's actually very easy to do, and that's the investment you need to do. But it's a one-off investment. I mean, sure, you need to maintain that as well, but it's not nearly in the scope of maintaining servers and networks and all that. Yeah, so that's basically what I'd say. I think it's a really nice way of building applications. It's light, it's fast, and you focus on actually writing and doing what's fun. Yep.
Have you run into any obvious downsides of this architecture?
Except for the initial load times, no. But I forgot to say one thing with the initial load times, and I'm actually going to go back to a picture here. What we've actually realized is quite a good pattern, and it's not just for not just because of the initial start time. It's actually a good pattern of testing and monitoring your applications. What we do is that when we build our service, we have all the Java code for this. We have in a, I mean, it's one Git project, and we launched that, and it has all the Lambdas. But we also, in that project, we build monitoring Lambdas that actually are scheduled Lambdas that do use our interfaces here and create a heartbeat load on the component itself. And then we put on the metrics that we produce in the Lambdas, we put alarms on them, and that way we can measure and see that there is actually activity in the system, and have alarms on that. And it's a really nice way of doing so. I mean, if you deploy it to a QA environment, you deploy it there, you have the monitoring Lambdas coming in there. If it doesn't work, you get an alarm. Then the same thing moves into production as well with the same monitoring setup and everything. And we actually define the alarms in the same descriptor as we defined our Lambda. So it's all of the monitoring and everything is done within the same Git repository, basically. And the upside of that is that since we put a heartbeat load here, we don't have any initial startups because we have a minimum even load. And I would definitely use that pattern of having simulators driving a load regardless of the startup time. It's a good pattern that actually helps with this one downside I've seen. Any more questions? Yeah, from the back, Martin.
You mentioned that Lambda service for Java, Node.js, and Python.
Yes.
Tried Python, or is that something that you didn't try? Because if you didn't elaborate on that.
Yeah, so the question was if we have used any Python Lambdas. No, we've only used Java, and just recently this week started using Node.js Lambdas as well, but not Python. But it's, I mean, you're right, you're Python, and like with everything, that's for Java and everything, you need to create a zip file or whatever with all the dependencies in it. So you package your code and the dependencies and load it up. So it doesn't do, I mean, it doesn't resolve any dependencies for you. So you need to kind of collect your packages and put them into Lambda as well. And there is, I need to mention this because one of the first things people tell me when I start talking about Lambdas is like, and it's the old people that kind of were around in the 90s as well. Oh, so it's application servers all over again. Well, not really, because nothing is provided. And that's basically the big failure of application servers, was all the crap they provided that collided with all the stuff that we actually wanted to use. And since nothing is provided, you bring your own stuff always, and then I have no problem running stuff in a container that somebody else provides. Another thing on that, there's a hard limit on the Lambdas, and that's the fact that the jar file you upload for the Java ones cannot be bigger than 50 megabytes, so, which is a good thing, because that means that we stop building monstrosities that bring in the entire world and all of Spring into one huge thing that we try to deploy. So we actually keep things small. Yes?
How do you set up the production and QA environment? Are they different Amazon accounts, or?
They can be different Amazon accounts, but what we actually do is that we want different environments in the same account as well. You probably want to have production in your own environment and the non-production in another environment. And there's different reasons for it. Basically, one of them being limits. You have you don't want usage in QA affect your usage limits in production. But naming is basically what we do. So a Lambda is named, for us it's prefixed with solution and environment, and then the name of the Lambda. Same with DynamoDB tables, they're also prefixed, and APIs also have the solution and environment prefixes in them. So by basically naming convention, keeping them separate. Since there are no networks or anything, everything is exposed on the public internet. God, behold, dangerous world. Any more questions? There was one over here in the front. At the same time. Yeah.
Is it possible to achieve this with Azure?
To achieve this with Azure, I think that he will talk about that. I know that, you have functions. I don't know if you have anything similar to Kinesis streams, and I'm sure you have something similar to API Gateway as well. So it's... I think this, you'll see this from all the big three with Google as well, being able to build similar pattern. And that's why I think this will be the big thing everybody talks about in the next 5 to 6 years. And this will seriously dampen the hype of Docker as well. Because even though Docker solves the portability issues we've had, it doesn't solve the networking. It actually adds another layer of complexity on networking and stuff like that. So you actually want that to go away as well. So, yes, one more.
The downside be that if you choose this, then you're very locked on Amazon.
As long as you are good at maintaining your interfaces, you have an interface. Then if you want to migrate to somebody else, well, then you implement that interface in their technology. And we're so afraid of the lock-in, and we do so much on a daily basis. We have been doing with not to lock into Oracle, or so we can change relational database one day. We have done it in 20 years that I've been working like once, and I've been maintaining more complex code in order to do it. So what we save in actually building lightweight, quick, easy applications, focusing on just building value and not the crap around. We save so much more in doing that when we need to move, if we need to move, then we'll rewrite it. And it is in this case it's quite clean Java code. Of course, if it's not a Kinesis stream, if it's not a DynamoDB, then you'll probably rewrite it anyway, but it's still that's my rationale, that if you actually go all in, then life is going to be so much easier, that you save so much more money. Yes.
Quite a good argument you have there about the lock-in, but how do you know Amazon wouldn't suddenly just raise the price?
Yeah, I don't, and that comes down to my relationship with Amazon and how much I trust them in my relationship. And I'm not knocking the other big vendor that is here, but I'm going to knock a lot of other actual vendors. Because usually when you have your Red Hats, your IBMs, your Oracles, whatever, your relationship there is that you talk about license fees for a certain amount of years, and you can get a discount if you lock yourself in for 5 years, whatever. Here you pay based on a hourly or even at a 100 millisecond rate. And they actually understand that if you don't get value for money, you will leave. So our relationship with Amazon is actually them challenging us to build better applications so that we pay less. By doing that, they realize we become more satisfied, but they actually free up a lot of their infrastructure so that other paying customers can use it as well. So they get better utilization by challenging us to pay less, which is a very healthy relationship. So, and I think it comes from that relationship that I kind of feel quite happy being with Amazon, and I'm not really worried about any sudden doubling of prices. We have not seen it yet. Amazon has only decreased prices.